Hello, Jeremy here. In this video, we will talk about mutable objects in Python and how they are used. The most common mutable objects in Python are dictionaries, lists, and sets. We will cover all three, so let's get started. Okay, I'm going to go ahead and open up the repo. So, what a mutable object is or means is it's immutable. The object is mutable, which means the object can be changed. This is in contrast with immutable, and an immutable object cannot be changed. So there are two common objects that are similar, but one is mutable and the other one is not. So the first one is a list, and the next one is a tuple. I'm using these horrible abbreviated names because if you spell them out, they're actually keywords. List is a keyword, tuple is a keyword. So I don't want to overwrite them. Okay, so with a mutable object, you can change it. So list.append, I'll append 5 to it, and I can show the list. You can see that 5 has been added to it, so the list has been mutated, been changed, been updated. We try to do that with a tuple, it won't let us. I don't even think it has an append method. Yeah, it doesn't have an append method. Another way you can append something is with the addition operator. So if I want to append a 6, I can add 2 lists together. So this list plus this list will concatenate the 2 lists, which means to merge them. And we need to do that. So this actually doesn't update the list. This does the concatenation and returns the result. So that list is not updated. So to do this, you need to say list is equal to the combination of the 2, and then you have this. However, this is a bit devious. So I actually have to show you this anew. Here, let's do 1, 2, 3. In Python, we have the ID function. What ID does is it tells you the ID of that object. Each object will have a unique ID. What typically is done, I don't think it has to do this, but typically what is done is this is the address of the ID in decimal. If I wanted to print it, print, I think it's just something like this. I don't remember how it's done. Keyboard. Yeah, I know. It's all invalid. I'm trying to get parentheses around that. ID of list. Okay. Alright, so 50% X. I forget how to do this. So I'm going to go and internet search Python xprint. And string.decode X. Okay. So let's see here. it said that you can do, you can say hex int, and this is a bunch of stuff here. ID is list. So 16 is base 16. Not convert. Non-string with the explicit base. We'll just, I probably don't need this int then. I'll just do this. Yeah, okay, there's the hex. So this would be hexadecimal notation. So here's the address. There are, should be 4. Eight. Oh, it's not showing leading zeros. It's annoying. 12. Unfortunately, it's not showing everything. But what's happening is these leading zeros are being chopped off. So we have to pad for that. But anyways, this is the address for the list. So what I'm going to do is show you that when we create so if I say list, that's that list. If I say A equals list, and we go, we print the A. That's just wrong. That shouldn't be happening. Should be the same. Because there should be a reference to each other. A is list. Oh, no. List. There we go. See, the ID is the same. ID is the same. It's the same memory location. So that was the problem. Right. So when you assign, when you do an assignment, the ID is updated. It's the same thing. So when you do equalities, you are actually creating pointers. You're saying that it's at the same address. And when you say B equals 1, you're pointing B to the 1 object that exists in memory somewhere in Python. So the Python interpreter has allocated the 1 as an integer object and is pointing to it. All right, so now going back to the list. So when we had the list and we appended to it, like a 5, look at the ID of the list. It's the same ID. You can see that it is same ID here and here when we appended. So we're pointing to the same address in memory. And therefore it's referencing the same object. We've just added more data to the end of that list. You know, 1, 2, 3, 5. So we do the other way, list equals list plus 6, adding two lists together. This is different. So we go ID of list. Notice that has a different address. This is because when Python combines the two lists, when it concatenates them, it smushes them together. And this is a new list. And then you are saying, take that address of the new list and let's list is assigned the address of the new list. So this is a new object. And the old list is no longer being referenced by it no longer has a name anymore because we said a list has a new name here. The old list is no longer being referenced and it will be destroyed. Okay, so this is what mutability is about. Now, immutability, that tuple that I made, what was it, TPL? ID of TPL. Now, as we saw before, we cannot append to it anything. It doesn't have the ability to append. But what you can do is you can do the same thing that I did with the list. TPL equals TPL plus 3. Okay, this is a little tricky. I'm going to do this because, well, I'm going to show you this first. So this is a weird behavior that is odd because you would not expect this. You'd go, well, this is a tuple. I'm adding it to a tuple, so it should work. The issue is it's not seeing these parentheses as a tuple. It's seeing these as grouping, like so. That's what it's seeing it as. So you want to add a tuple. Tuples are denoted by the comma, like so. So this says, now I'm adding tuples. And that allows me to add it together. So let's make this a 4. And so, because this is taking the tuple, adding or concatenating the 4 to the tuple, and making a new tuple with that data, it's not violating mutability principles. Mutability just means you can't change a existing object. So we can do this. And you see the ID of the tuple now, the TPL, is going to be different from the ID before it. Yes. All right. So this is the idea of mutability versus immutability. What we can do with that is we can make a list outside, define a function. Let's just say append, and we can pass in a list to it. And the whole thing this function does is l.append to append 9. And it's that. So when we call 10, missing required one positional argument. Oh, I'd have to say list. Let me say list 9. I'll append again 2 9s. I'll append again 3 9s. So that's a pretty clear example of the fact that this gets passing, the address for this list, and we are using that to append 9s to that list that exists at that address. If the list itself was being passed in to this function, then it will be a copy of the list was being passed into this function. The copy of the list will be updated here, and we would not see it update in these other ones. So it has to be a address that's passed in, and we are manipulating the list that's at that address, which is what this proves. This is a little bit different than if we say equals 4, then def, I don't know, add. Then we give it a parameter and go and say a equals a plus 2. And we say add x. X is still 4. X is immutable, and a copy is passed in when we handle this. Well, that's not exactly true. The reference is passed in here, and this syntax is A is the reference to whatever object corresponds to 4 plus 6, 4 plus 2, which is 6. So let's try this. Let's say ID of X, ID of 4, ID of 6, ID of X plus 2. Yeah, see, it knows. It's pointing to 6. So when you add these two things together, it's pointing to 6, and that new address is stored in A. Okay, well, that's interesting. So actually everything seems to be passing addresses in. Python is like that. Okay, that's the list. The next thing is the dictionary. All right, let's go with a set. So a set looks like this. 1, 4, 7. And we can't have duplicates. I showed this before. But what's another example? What can that hurt? Okay, sets are mutable. You can add to them, and I think it's set.add. You can add a 9. And now, right? So there's the set, and it's been a 9 has been added to the set. This is how you mutate a set. A set has some other operators. 1, 2, 3. This is the union operator. 4, 5. That combines sets. Doesn't allow doubles, of course. No sets allow doubles. There is the intersection operator, which is this guy. So that tells you what sets are in common, what elements are in common. Then there is subtraction, which takes from this first set, subtract out the elements that are in the second set. So remove them. If there's anything that doesn't exist in the first set, it doesn't do anything. So this 5 does nothing. So this 4, so try to get out this 4. And then there is this mutual difference, which is this guy. Or symmetric difference, I should say. So you can see here that the 4s are in common, so those get removed, but 5 and 3 are, these are added together. So only the set elements that are in common get removed. But otherwise they're combined. This is related to XOR in some way. I need to think about it. This is related to AND, and this is related to OR. And I'm not going to get into that, but that's some mathematical background. You can try to figure out how this is related to AND, OR, and this is related to AND. And you can figure it out. And this is related to XOR, I'm pretty sure. So now we got those guys. The last thing is a dictionary. We haven't used dictionaries yet, but they're actually pretty common. And the way you do a dictionary is, it looks like a set, but it's different. It has a key and a value separated by this colon, and then a comma for the next key value pair. And these can be, the keys can be anything that's immutable. Strings are immutable. You can't change them. Much like tuples. Tuples are immutable. But lists and dictionaries and sets you cannot use as keys because they're immutable. They can be changed. And the speed up that dictionaries use requires the keys to be immutable. The values can be whatever you want. So you can use numbers for keys because numbers are immutable as well. And I could use a dictionary for a set for a value. Let's see this. I have no problem with this. So the cool thing about everyday dictionaries is I can look up things with a name. So this says look up the element that has the key named key. And it is value. So that's cool, and then we can also look up key 2. And just to show you that you can use 4 as an index. This is a little weird because it looks like this is a list, but it's actually a dictionary, so this is pretty rare to see a number being used as a key, but it's possible. And it's really common to see strings as a key because people like to use strings to mean what they're looking up. It's highly common. Alright, it's also possible to use a tuple as a key. So you could say, I don't know, let's say, and this corresponds to some sort of user object. Yeah, users. I know. Calm down. Say class user has. And it'll allow that. So here, when we look up, we have to use isolate password to look it up. And that will reference the user object. And you could also, so all of these objects are containers, and you can use in. So you can say, is this in D? That is true. You get the password wrong, not in D. This could be used to do like a user password check or something like that. You can do many things with this. Dictionaries are very useful. So, and dictionaries can also be updated. You can update a dictionary with, let's say, ID of D. And we do d.update. We can update it with a new dictionary. And we're going to add Joe, password schmo, like that, I guess. And that's some user. Cool. And that's the dictionary update that we want to do. ID of D, should have the same thing. And we should have the dictionary with that new element in it. So we have updated, we have mutated the dictionary. Okay, so that should cover dictionaries, lists, and sets. Show you how to update them. Oh, another way you can update a dictionary if you wanted to is you can say, erg Bob equals, and this is another way that you can update the dictionary. And it is the same address still. There's a way you can always copy. You can do a shallow copy is to do d1 equals dict ID of d1 ID of d. You can see they're different IDs, so they're copies. D1. You can update D1. You don't make it. D1 equals 42. D1. That's that. And D. That's not. So now they're separate dictionaries at this point in time. Because we made a copy and we updated. And to show you that if we don't do that, D2, D2 of 1 equals 42, D2, you can see they're the same because we're updating the same point in memory, so they're the same object, just referenced by two different names. So they are the same object in memory that we're manipulating. This goes for any object you can mutate. So knowing if your object is immutable or not is really important because a mutable object can change behind your back in some other function and you may not be expecting it. Immutable objects cannot be changed, so you don't have to worry about it with those. This is why it is preferred to work on immutable objects as opposed to mutable, but sometimes the immutable object just might be necessary. All right, that is my presentation on mutable versus immutable objects, and lists, sets, and dictionaries. I hope you have a good day, and see you next time.